Good afternoon, everybody, and welcome to TGIK number 84. In this episode, we're going to be exploring the changes that are coming up in 1.15 release of Kubernetes. Sorry, 1.16 release of Kubernetes. So it's still a release away. We're still kind of playing around with 1.15, but 1.16 is baking right now. So it's coming soon. You don't have a lot of time, uh, but yeah, let's talk about it a little bit more. Um, what this episode is going to be about is about the fact that, like, in 1.16, a bunch of the deprecated APIs that have been being served over time are going to be removed from the Kubernetes API. And in this episode, we're going to explore some ways to see how that will affect you, what to do, and how to fix it, and those sorts of things. And we're going to kind of walk through some of those examples. So I'm really looking forward to this one. This is another episode in which I will shout out to Kind because I'll be using Kind clusters to do validation of those things and that sort of stuff. And then yeah, that's what we're up to in this episode. Let's take a look at our chat. 1 second, let me get that set up here. All right. Hello, Martin from the Netherlands. Hello, Robert Keelty. Hello, Lamati. Good to see you. Rory from Scotland. Always good to catch up with you on this. George is back from vacation. He just had a lovely time in Crete for a bunch of time, and he's going to join us here to kind of like help moderate the chat. So if you have questions that I miss him, he'll let us know. Maruf from Bangladeshi, and Andre from Brazil, Bogdan from Romania, and Joe from Kyoto. You should be sleeping, Joe, but I understand that jet lag is a thing. Rafal from Poland, Kofang from South Korea, and Herman from Berlin, Germany. Hello, everybody. It's great to see you. I love that it's such a worldwide audience. It's like so incredible that, here I am sitting on my laptop in beautiful San Francisco, California, and talking to all of y'all live all around the world. It's such an incredible thing. Hello, Joy from Richmond. Is that Virginia or California? I think Richmond is one of those city names that is like everywhere, like, so I'm kind of curious. Um, oh, Virginia. Okay, cool. Yeah. So, welcome, welcome, welcome. So, what we do next usually is to kind of go through some of the weekly news here, and let's flip the camera over to that screen and start digging through that stuff. So this is our HackMD, and George has already put up a link on our to our HackMD. If you want to contribute or mark where I am on time, or if you have some ideas about things that I could talk about this week and you think I missed something, go ahead and throw it in there, and then I can actually talk through those things in this episode. The first thing I want to start off with is something that really impresses me every time it happens. The CNCF has a kind of a blog webinar series in which they usually present one thing or another. And what they do is, like, every time there's a new release of Kubernetes, usually there is a really great and very informative webinar around what's coming in that new version. Ken Coleman is somebody I work with here at VMware, and he does an incredible job. I can't say enough about how great this is of really just giving a really good, deep, and yet somehow concise overview of everything that is coming in 1.15. It's really incredible. I have an echo problem. That is odd. I don't see an echo problem. I'm going to go ahead and close this page. It's the only place it could be coming from. And hopefully that will go away, but do let me know if it doesn't. All right, so yeah, Kenny Coleman's intro to what's coming in 1 second here. Let me get the chat back up live. Okay, cool. No echo. All right, good. Well, thank you for your help. I was like, oh no, not an echo. All right. Anyway, so let's keep going. Yeah, so like I said, Kenny Coleman. It's almost like if you've ever watched like the What the Frack episodes of on like Battlestar Galactica, where somebody like gives you like an incredible view of like the storyline and where we are in it. It's kind of feels a little bit like that. It's really great. So that link is in the That link is in the HackMD. Feel free to check this out. It's just an incredible amount of detail and an incredible, and yet somehow still incredibly concise. The next thing up, one of the merges in 4 days ago, which was actually, so like, this is actually coming from the last week in Kubernetes.info, lwkd.info page, which basically gives you a kind of a view into what's happening with the code base within Kubernetes. This one is exciting to me. I think this is something that I've been kind of waiting for to happen for a little while, and I know there's been a lot of people working on it. What this one does is it adds ephemeral containers to the Kubernetes Core API. And the reason that's interesting is because it is one of the building blocks necessary to allow us to do things like schedule a debug container that would be coupled with an existing running pod. And this is really useful for those scenarios in which you have a misbehaving application, but you don't have the debug tools necessary to really kind of inspect what's happening. And you really want to get to that understood, you want to get to that broken state and kind of dig in, right? And so the only way that you can really do that, like one of the ways that people frequently ask for is that they're like, can you bring up another container that has access to that running pod that I can use to kind of debug the state of that pod so that we can dig into what the actual problem is and maybe I can fix it. Well, this proposal and the work associated with this proposal is actually trying to actually provide that capability, which I think will be great. I think opinions vary. You can see that there's an interesting dichotomy here because, like in one case, I'm saying, you know, if you end up in a pod with a broken state, you should actually enable the developer or an operations person to debug and understand that broken state. And on the other hand, we have like SRE principles and some of the more operational principles that say, if it's in a broken state, you throw it away and you bring one up that isn't broken, right? And it's like that's kind of, I think, kind of an ongoing dichotomy between the two camps there. But at the same time, it's great to see that there's still that we're doing work to kind of further that here. So that's really cool. And who else do we have logging in here? We got Herman. Joe, are you at the Open Source Summit? I don't know. I think Joe's actually on vacation, which is awesome. One second here. And we pop this out. And then we have Dims from Boston. I didn't know that Dims lived in Boston. Are you living there, do you live in Boston, or are you visiting there? I'm curious. And then we got Marco from Milan, Italy. Italy is like such an incredible place. I was actually just talking to George about my trip to Italy. I got to visit Venice while I was there and Cinque Terre, kind of tripped around a couple of different areas, kind of like in that upper part of Italy, and really enjoyed it. It was just incredible. Um, oh, Dims actually lives in Boston. Well, that's awesome. Well, thank you for logging in. Good to see you. We have Olav from Copenhagen, Denmark. We have Alexis from France. Hello, hello. Again, such a worldwide community and such an awesome thing. All right, so we talked about ephemeral containers and how that's coming in. Right now, obviously, this was merged 4 days ago, so this is still, you know, some releases away from you actually being able to put your hands on it and play with it. But it's interesting that it's coming. You know, it's kind of interesting stuff. The next one up in our Cube Weekly, or in our weekly news, is a really interesting one about how a production outage was caused by Kubernetes pod priorities. Let's see what's happening here. So a 30-minute outage was what happened to the hosted Prometheus service, and some customers were affected. This is them being very transparent about what happened, and I think that's great. I love it when companies actually like put up things that help us all learn from the experience, because like if we can learn together, we can really go very far together. You know, like if you're learning in isolation, it's very hard to really like to level up. You know, and so I love it when people put up things like this and describe what's actually happened here. So the Grafana hosted Prometheus service is based on Cortex. To achieve zero downtime. Cortex ingester service requires an extra ingester replica during the upgrade process. This allows ingesters to do things. But ingesters are big. They require 4 cores and 15 gigabytes of RAM per pod. 25% of the CPU and memory of a single machine in our Kubernetes cluster. In aggregate, we typically have more than 4 cores and 15 gig of RAM of unused resources available on the cluster to run these extra ingesters for upgrades. So basically what they're saying is that when they spin up a new deployment of this set, they have to kind of spin up an extra one to kind of hold them over to in the migration to the new version. However, it is often the case that we don't have 25% of any single machine empty during the normal operation. And so you can see how this would slip through the cracks here. Like this is the thing where you may not actually have enough room on a single machine, although in aggregate you do have that much room. So it's a little misleading. Let's see what happens here. So on Thursday, we deployed 4 new priority classes to our clusters: critical, high, medium, and low. And we had been running these priorities on an internal cluster with no customer traffic for 1 week. The medium priority class was set to be the default for pods. They didn't specify explicit priority. Ingesters were set to high priority class, which would mean that the ingesters would have a higher priority and thus be able to kick other things out when the time came. On Friday, we spun it up. Cortex ingesters are stateful, holding up to 12 hours of data. So replica set for preempted ingester on our production Cortex cluster. Notice the preempted pod created a new ingester pod to maintain the correct number of replicas. And it's battling. This new pod was given the default medium priority. As such, preempted another production ingester. This caused a cascading failure that eventually caused the preemption of all the ingester pods for the production Cortex clusters. That is pretty awesome. Yeah, so now that you have the power of actually ejecting other pods, you still have to kind of think about how that's going to balance out. You don't want necessarily this cascading failure model. So that's an interesting one. That's about as much detail as I can spend on this article right now, but it is a very good read, and they go into some detail about what's actually happening there. They talk about their takeaways and what to do and what they learned. And again, I can't say enough about that. When I see companies out there doing that stuff, really? Am I still only showing my face? Oh, wait, what's happening here? Something's weird. Something strange here. Hold on one second. Let me see if I can figure out what's happening. Oh, I'm having a refresh problem. Okay. Thank you for pointing that out, Joe. Now it seems to be working correctly. That is odd. Okay. All right. Weird refresh issue. So the page I was just reading through there, thank you, Joe, was basically this how a production outage was caused using Kubernetes and pod priorities, and it is available in the HackMD, so definitely go check that out. The next part of our chat is Beyond Hello World, Modern Asynchronous Python Application in Kubernetes. Another great article talking through some development patterns for Python and how to basically develop a pattern within Python that would put you in a pretty good position if you're leveraging Kubernetes as your platform. So that's definitely worth checking out. Wait, yeah, okay, cool. The refresh problem is gone, right? Like you can actually see the right page now? Okay, good. All right, good. So definitely check that out if you're interested in Python, or if you're just interested in exploring the patterns that might put your application in a better position to kind of thrive in a Kubernetes environment. So like that's a really great article that kind of talks through some of those things. Next up on our list, we have a business executive guide to Kubernetes. Now this is I think a spicy one. It's interesting. So this is actually from Jess Frizzell. And many of the things that she highlights here are still very much top of mind for a lot of people who are adopting Kubernetes. And some of them are, have aged better than I think the article lets on. Like There are some references to a default dashboard that isn't a default dashboard inside of Kubernetes. We've spent some time in a TGAK kind of talking about how to configure that in a more secure way. But it does highlight the fact that, like, even though in our case the dashboard is not default inside of Kubernetes, it doesn't mean that the problem itself doesn't exist, right? Like if you deploy an application and you're not actually spending the time it needs to secure that application, that's still a problem that you're going to have to deal with, whether it's on Kubernetes or on any platform. It still calls attention to the problem that is related. Upgrading Kubernetes is still a tricky thing. There are some good examples of patterns for how to do it and patterns to watch out for. And yeah, I mean, I just spent this week working on a presentation that I'm going to be giving with Ian Coldwater in a couple weeks at Black Hat. And in the presentation, we're talking about what we mean by Kubernetes defaults, right? And so this is really highlighted again to me this week that Kubernetes is complex. If you're thinking about it from a security surface, there's a lot to think about, and if you're thinking about it as a development surface, there's a lot to think about. I think it's worth the price of admission, though, because there's a lot of reliability in the system, and I do think that having a single API with which to reason about all these things cannot be understated in its value. I think it's a super valuable thing. So it's an interesting article. Check that one out. I would like to give a shout out to all of the people at GopherCon, including my friend Eric Chang, who I worked with at CoreOS. He's a great guy. And he actually wrote a presentation for GopherCon this year that is called PKI for Gophers. I highly recommend it. Eric is probably one of the sharpest PKI folks I know. And I think that was true of a number of people that I worked with at CoreOS. But definitely check this out if you're looking at how to, understand how TLS or HTTPS works within Golang, and you wanted to kind of like have a pretty good primer for how to understand that sort of stuff. It's a great presentation, and I'm looking forward to the recording when that finally gets released. But he's just one of the many, many, many amazing people that are presenting things at GopherCon this week. I'm kind of sad that I'm not there, but like, can't say enough for yet another incredible community. I mean, the community of Kubernetes and the community of Gophers in the world are very. There's a huge overlap between the two, and there's also just an incredible number of people who are just amazing in both of those communities. Like I can't say enough about it. Anyway, the last thing in our list is basically kind of the story of like what we're here to talk about. I'll make sure this is muted, and it is. Okay. So this is the blog that kind of brought to mind this particular episode, and you should read it in detail if you have not. It was actually authored by Valerie Lancy, who is another incredible engineer in our community. She's taken on the world. Like she's just doing so much great stuff for the community, including this blog post, spending a lot of time in SIG Network and a lot of other places. But this blog post, as we get into it, I'm not going to read the whole thing to you, but we are going to spend some time on the finer points before we start exploring how this might affect you and how to solve the problem. Before we do that, though, let's go back to chat and see how we're doing on the chat stuff. So, Alexis from France, hello, and Sam from North Carolina. Alexander from St. Paul, good to see you. Rafal, can you show the page? Sorry about that. Show the page. I did fix it, I hope. I'm sorry that it was I was freezing up there. Looks like it's all good now. Paulo from Montevideo, Uruguay, I hope. I'm not slaughtering that too much. Abanov is asking maybe a question. Dims is replying to a question. Oh, you're talking about the timing. Yeah, the timing is hard because the problem is there's no perfect time, right? There's no way for us to pick a time that is like going to be perfect for everybody. And so it's like we just have to, that's why we record them though. Like if you can't make it in person, you can always just jump into the chat. If you have other feedback for us about the session, the comments usually remain open for a little while and we try to actually reply to them. And then we also have the GitHub repository where you can actually file issues for things that are coming that you want us to talk about, and actually just provide us feedback that way as well. Obviously, I'm Maui Lion on Twitter, so you can reach out to me personally if you have something you want to chat about. It's just not timely, and I'll try to get back to you as well. So it's a, it's a, yeah, it's there's no perfect solution to that particular problem. What else do we have? We got Rory talking about Black Hat. I'm like, I know, I'm like super jazzed. And Joe shouting out to Valerie. Awesome. We have Stevo debugging ephemeral containers should be safer than exec into one of the running containers. That's true, actually. But at the same time, like from a security service, I'm still kind of racking my brains around it. But it is pretty awesome. I'm really looking forward to it. Fabio from Brazil, good hello, and Christopher from Germany. Great to see you all. And Joe, my buddy Joe, my other buddy Joe. So many buddies, Joe. Anyway, my buddy Joe from Atlanta. I hope you're looking forward to the weekend. I know I am. So let's jump into this blog post and talk about what's happening here. So first, I want to define some terms. And this first sentence, I think, says it all. Whoops. And let's just define those terms right here. So up in this first sentence, it says deprecated APIs removed in 116. Deprecated means that for quite a while, like some time ago, a particular API path within the Kubernetes API has been moved to another path. And the old path has been marked as deprecated, meaning that ideally you would move toward the new path. An example of that is the deployment object, the humble deployment object, the workhorse of Kubernetes. So the deployment object is now inside of apps v1 and has in previous versions been inside of extensions v1 beta 1. It's been in apps v1 beta 1 and apps v1 beta 2. It's been in a lot of different areas as the API was maturing and changing. And what that means is that a number of manifests out there on the internet that were designed during those previous versions of Kubernetes probably still have the API version set to like the older deprecated API version. And in 116, we're going to remove those from the API server, which means that if you try to create a manifest that has that old API version in it, you're going to get rejected. And I have plenty of examples of that we're going to walk through so you can see how that works. But I do want to make sure that we understand the terms, right? Deprecated and removal are two different things and happen in two different time periods, right? So even though these things have been deprecated for some time, they've still been in the API server being served. And so the user experience has been, well, I can deploy any deployment manifest and it will work inside of Kubernetes. And the user experience is about to be, actually, that manifest has to use the correct API version to be deployed into Kubernetes. It can't be any version anymore. And you can see that dichotomy there. And I'm expecting that to provide some friction for people as they move into 116. But yeah, so that's what I wanted to highlight is that it's the difference between those things, right? Like it's pretty darn important that we understand that deprecated does not mean removed, but now we are actually talking about removed. Those older APIs will not be available in 116. And it's super important that you understand that. And they also try and give you a heads up on the fact that in Ingress, extensions v1 beta 1 won't be available in v1 18, which is 2 releases from now. But in 116, we're going to start feeling that. We're going to start feeling that pinch, and we're going to talk about how to do that. So as we move down the blog post, we also see ways to actually bring up a cluster to validate this. And so in my setup that we're about to go through, I'm going to walk you through how I set up the environment so that I could use to validate these things. And basically I did exactly this thing, right? So in the runtime config, which is a powerful capability of the a powerful flag inside the API server, you can actually turn off particular API groups using the runtime config. And so if what you wanted to do was validate that your manifests were going to work when you upgrade to 116, which I highly recommend you do, one way to do that would be to spin up a 115 cluster with this flag enabled, or with this flag configured as described. And what that would allow us to do is prove when we try to apply our existing manifests against that 115 cluster with the APIs removed, that we would be able to get to understand what that user experience is going to be like. And that is kind of the point of this episode, is to work through that and show what that looks like and what that user experience is, and make sure that we understand what's coming and how that will affect us. This was previously announced in 1.14 and in 1.15 in the Kubernetes development chat. It's been talked about a number of times online, and we're obviously going to spend an entire episode focused on it here. So I hope that is enough I hope that's enough signal boosting, but feel free to tweet about it and get out there and tell people about it. I think it's an important one, and I really, from an empathic perspective, I'm like, I can feel the pain coming. I know that people are going to be really surprised by this, even though there's been Kubernetes blog posts and lots of notice about it. I know that people are still going to be caught on their heels on it. So help me spread the word. Please help me spread the word on this. It's a big one. Oh, conf test. Yes. Conf test is a great point. Conf test is another way. Actually, let me just pull that up. We'll look at it real quick. Yeah. So there's this project that was actually, I meant to put this in my notes. Thank you for calling that out, Joe. Conf test is a relatively recent project, I think. But what it does is it allows you to use Open Policies Rego to write rules to validate a set of manifests, maybe as they lie on disk rather than as they are submitted. And so what conf test can do, and I don't know if there's an example of this for the expired APIs. It'd be kind of interesting if there were. Yeah, I don't know if there's an example of this particular case. That might be kind of a cool enhancement. But yeah, what it can do is it can actually just leverage the Rego API to kind of describe rules and then inform you when things are not conformant to it. So it'd be great to see an example that allows you to take the older APIs that are no longer viable and prove that those older APIs and like warn you about the fact that you've got objects inside of a repository where there are a bunch of manifests that are going to break when you move to the new version. So yeah, that would be really cool. QBval is also interesting. Yeah, there's a ton of, instrument A is, or Instrumentia, instrument A, what have you. Yeah, that's right. Gareth Rushgrove did do a demo of conf test in the community one, and that was really great. What else do we have? Lamati thinks DIMS was thinking might be useful to check for the. Yeah, that's true. Yeah, that would be good. All right. Yeah, I think there's like an approval thing that has to happen if there's a URL, and I'm not sure how that got turned on or how to turn it off, but this is like kind of one of the newer features of the YouTube live event thing. And it says you could be a moderator, but like even as a moderator, I couldn't figure out how to like approve those things. So I have to spend some time on figure out what that's all about. Moving on. We have, yeah. So that's the blog post. That's the info. Help me get it out. Take this link and spam it everywhere you can, and like make sure that people that you know that are using Kubernetes talk about it at meetups. Like, get the word out. I think it'd be really important to chat with it. And since we have such an incredible audience, kind of all over the place, help us get the word out in every direction. Like this should also be a distributed system. It's great stuff. All righty. So, anything else I wanted to talk about? Oh, actually, yeah. Kubernetes deprecation policy. This actually talks about the policy behind deprecating and removal of things, and it's definitely worth a read. But it talks about both the promotion of APIs and also the removal and deprecation of APIs, and it's a good one to read for sure. So, if you're curious, like what the life cycle of an API or API versions and stuff within the core Kubernetes project. And I find that generally things even that are not in Cora follow the same pattern. So if you like look at Cluster API or any of those other things, KubeADM, well, KubeADM is in Core, but you get the idea. Like other projects are following the same pattern because it's a pretty well established pattern. So it's a good article to read if you're curious about that sort of stuff. Moving on, Docker 1903 was released. That's worth talking about. There's a lot of stuff in 1903. I'm not sure that it's actually trusted by Kubernetes yet, but I'm looking forward to it. There's a bunch of stuff that's actually happening here that is actually pretty neat, including some of the changes from Akiro going into Docker 1903 that allows you to do this to run it as the daemon itself as non-root. I'm not sure if that work is complete yet, but I know that it's being merged in. So yeah, good stuff. There we go. Yeah, allow Docker D as a non-root user in rootless mode. So that's some of the stuff that's coming in. Rootless support for LXC user NIC, which is a network interface that we can associate with the pod side of, or the Docker side, Docker container side of the network interface without having to run as root. You know, really good stuff. Lots of exciting things happening still in the project. And it's actually, you know, remember that a lot of this stuff is not just happening to Docker, it's also happening to Containerd. So it's like exciting in kind of both of those spaces. So yeah, definitely good stuff coming, I think, to kind of help solve some of the interesting stuff coming with containers. And I think that covers our last week in review. Let's talk about the setup. Oh, yeah, let's talk about the setup. So, my setup, again, what I'm doing, let me make that bigger. Probably a little better. Good, you can still see that. All right. Podman. You know, I haven't explored Podman too much. Podman is interesting because I think it's one of the very few projects that can make use of cgroups v2, which provides kind of a better delegation model for things. I explored a question on Twitter recently. It's like the question was like, when you think of Docker and Docker, what do you think of? And the two answers were like, one was that you give in the Docker container enough privileges to create containers itself, and the other one is that you mount in the Docker socket and you allow for something inside the Docker client inside the container to make use of that Docker socket and create containers on the underlying host. Both of these two patterns do create containers on the underlying host, but they are intrinsically different. And in that conversation, a lot of things really came up, and I thought it was really interesting. One of the things that came up was around understanding how better to delegate resources if you're going to do the Docker and Docker thing, in which you are actually creating containers from within a container, not making use of like a Docker or Containerd API directly, but actually just exploiting those primitives within the Linux kernel directly. And if you do those things, like how can we better police what resources you have access to, right? Like you should really only be able to delegate the resources that I've given to the container, not necessarily allocate new resources from the Linux kernel to the new containers that you're creating. You should just be able to kind of like sublet, not lease out a new apartment. I hope that kind of makes sense. So Podman is one of the projects I think that actually makes use of cgroups v2, which is actually a step in that direction. And I think that that's a pretty interesting project because of it. And I think that containers in general, as they walk down that path, will continue to get better and more, I don't know what's the word, not resilient per se, but like that we can make better decisions about how to provide delegation of resources within kind of the container model. Maybe that's kind of what I'm trying to say. All right, what else do we got here in the chat? We have Marco talking about CI tests. Yeah, that's another one. QBval, that's a great one. Yep. Instrument A talking about QBval. Maybe we'll explore QBval in this chat. We'll see. We have Lamati talking about rootless containers, asking me that question. We have Waleed from Amman, Jordan. Hello, Waleed. All right, so my setup. I've got my my Intel NUC over here on the left of my screen. You can't see it, you know, but I'm doing that because like my laptop is just like a Lenovo X1 Carbon, and so I kind of need the processing power of the laptop to make sure that the stream stays reasonable. And so instead, I'm kind of farming out the creation of containers and my clusters to my NUC, which has a much more powerful CPU, much more RAM, and that kind of stuff. So I'm using kind to create clusters, and if I do kind get clusters, I can see that I have two clusters that are created. And to create them, I've created these two directories, APIs and no APIs, which are the names of the two clusters. If I go into APIs, I can look at the configuration for it. And the configuration in this case is basically just kind of the standard configuration that I use for a kind cluster, in which I'm turning off the default CNI because usually I want to explore one of the other CNIs like Flannel or Calico or one of those other things. And this enables me to disable the CNI directly and then just apply whatever CNI is interesting to me. I have described the nodes that I'm going to create. I'm going to create a single control plane for this purpose, and I've got 3 workers. And then down below, I'm actually providing a kubeadm configuration patch that allows me to override some settings in kubeadm. For example, in this case, what I'm doing is I'm setting the pod subnet to match what the default is for Canal or Flannel. But if I go and look at the no APIs directory, this one's actually got a more interesting configuration. Inside of the no APIs directory, this configuration describes an override setting for the API server in which I'm providing an extra args argument, setting runtime to that same string that we saw in the example. And so what this lets me do is create a kind cluster, which is just running locally in Docker, that allows me to simulate the pattern around turning off those APIs in a 115 cluster. So in both of my clusters, I'm running kubectl version. I'm running 115 in both clusters. The difference is that in one cluster, I've turned off the suspect APIs that are going to be removed in 116, and in the other cluster, I have not. So let's explore that a little bit, and then we'll kind of get into this a little more. If you do want to know more about Kind and how to actually create clusters with Kind and how to interact with it, I do recommend that you either jump into the Kubernetes Slack and join the Kind channel, or barring that, you can check out my blog. I got a bunch of stuff on Kind. It's a really great group of people that is working on it. But I'm not going to spend a lot of time on setup here. I'm just going to like tell you that I've created 2 clusters, some that have those APIs, some that don't. So one thing I wanted to point out that I thought was interesting, if I do kubectl API versions, and let's just dump that to a file. API versions. Then we diff those 2. Maybe in the opposite order. What's interesting here is that we can actually see that the APIs, the part where I haven't turned off these APIs, do actually expose more of the versions than the one where I've turned it off. So what's neat about that, what I'm trying to highlight here, is that in your kubectl API versions, which is a way of understanding those versions that are available to you for inside of your cluster, we can see that some things have been pulled out and some things remain. So extensions do1 beta 1 still exists, but not for all the things, just for some things. And the things that have been removed are like apps.u1 beta 1 and apps.u1 beta 2 because there are no objects underneath that path that are still available. So if I do kubectl get API resources, no, sorry, just API resources, which is another command that is available to you via API. or via kubectl. Doesn't really line up on the version. So, all right. So, but what we see is that like when we turn these things off in runtime class or in the runtime config, we actually see them removed from the API in general, which I thought was actually pretty neat. You're not going to see those APIs like represented inside of the API structure or in the Open API document available within your Kubernetes cluster if you remove them, which I think is powerful because it means that you're going to be able to understand whether that's going to actually conflict or not. Other interesting things that are happening in between these two clusters. Like I said, we have the APIs turned off on one and turned off on the other. One thing of interest was to me was that so sometimes just for quick and easy Kubernetes networking, I still use Flannel for this, right? Because I'm not looking at necessarily at network policy. And so what I do is I go to the Flannel document or the Flannel repository, and in here there is, I only just now noticed this as part of testing this, and we're going to kind of walk through how this works, but there is a documentation. There's a kubeflannel document that they host. It's upgraded 5 months ago. And the kubeflannel document still refers, unfortunately, to the expired APIs. And so if we look at the configuration here, we can see that there is a daemon set that's being created, and it's being referred to as extensions v1 beta 1. And if we go back to these deprecated APIs, we can see that daemon set will no longer be served from extensions v1 beta 1. So that is actually our problem. But what I wanted to show you was like hands-on what that looks like when it doesn't work. So if I go into my existing API cluster and I do kubectl get pods all -a, I can see I don't have a network solution deployed. So let's go ahead and deploy kubeflannel. Everything works just fine. I can do kubectl -a get pods -a-w. And we can see that Flannel has come up and running. CoreDNS is now running. Everything works as you kind of would expect. But to kind of give you a view into what the UX is about to be, let's go ahead and deploy that same thing in our other cluster. So if I do kubectl get pods -a, I can see I do not have Flannel or any of those things running. So we're going to use the same exact argument that we did before, which is to deploy the kubeflannel manifest. And there's our UX, right? So it says that pod security policy, it says unable to recognize this manifest, no matches for kind, pod security policy, in version, extensions of v1 beta 1, unable to recognize the daemon set in this model because in versions extensions v1 beta 1. And so what we can tell from this already is that what we're looking at here is actually a manifest that is not compatible with this cluster because those APIs have been turned off. And this is kind of the user experience, I think, for people when they try to install some of those older manifests. So somebody was asking for maybe a diff between diff-u. So let's do that. Diff-u. No, that's not what I wanted. Really? Diff minus u. APIs. There we go. That gives you, I guess, some surrounding text. It kind of gives you a little more view into what's happening there. And so we can see that 2 groups have been removed. What this belies that what I was struggling with is that it doesn't tell you that even though extensions v1 beta 1 still exists, the stuff that's actually been removed, there is stuff that's been removed from that API group. And I can't figure out a way to show you that without like dumping the entire Open API spec and diffing that. And you know, in the words of many amazing people, ain't nobody got time for that. So what would have happened if you upgraded the existing cluster to the new version and existing resources had removed versions? Ah, great question, and we're going to talk about it. Okay, so here we are. We have deployed kubeflannel on the old one, but we were unable to deploy kubeflannel on the new one. What can we do to fix it so that we can deploy kubeflannel? And then we'll talk about that migration piece, which I think is important because it also talks about how the storage part works. But we'll talk about that here in just a second. So I've got my kubeflannel manifest here on disk. I've just downloaded it instead of trying to apply it directly. And if I do kubeflannel convert, now, kubeflannel convert is also deprecated. It will eventually go away, and the argument is that you'd be able to apply compatible APIs within the deprecation allowance, and you would be able to download the new version that way, right? So if you had a version that was not compatible, as we've seen in the last, I don't know, gosh, 9 releases of Kubernetes, maybe 8 releases of Kubernetes, those old deprecated APIs stay around for many releases. And so they're deprecating kubectl convert because it is actually a client-side thing, and they want to make it so that we don't have any client-side things. And so the way that you'd be able to work around the deprecation of kubectl convert is to basically apply that object to the cluster and then do a kubectl get at the desired version. And so we'll walk through that as well. And I think that's actually relating to the question that Dimitri asked. But first, I just wanted to call that out. So we've done kubectl convert -f kubeflannel.yaml, and what that does is it should actually result in a manifest that is compatible with the version of Kubernetes that I'm pointed at. So let's go ahead and do our diff -u again between kubeflannel.yaml and kubeflannel new.yaml. That is, oh, I see. The beauty of screen. Okay, sorry about that. All right. So what we're seeing here is that we're seeing things that are, some things that are changing in order because it basically is going to recreate the manifest. And so it's a little dirty in some ways to kind of understand how these things are related. But, you know, for the purposes of this, let's do grep API version. So, let's do grep -a1. So in our examples, we're seeing that on the left side, the old one has extensions v1, beta 1, daemon set, and on the right side, we're seeing the change to API version apps v1, still daemon set. Same thing over here for the for some of these other manifest parts. But basically, it's modified the group that is associated with this kind to the new version. So kubectl convert is one of the tools at our disposal to go ahead and make this change such that it will apply to the new version. So like RBAC, another one of the APIs that v1 beta 1, for example, is deprecated for RBAC. And in our example, which is kind of like hidden from us, it's been moved to use v1. If we look at the other changes, we can see the daemon set obviously moving from extensions v1 to apps v1. Metadata name to metadata namespace. That's interesting. I'm not sure that's actually going to play out. We'll see how that works out. It doesn't seem like it's quite right. I don't know why that change would have happened, but we'll see if it deploys and see what we're looking at here. So that's actually kind of interesting that it's changing the name of field ref. That might be a bug in kubectl convert, but let's try it. So now that we've got our new manifest, let's go ahead and do apply -f kubeflannel new against this cluster. Now that is interesting. So one of the things that did not get updated so it didn't actually change everything. So kubectl convert actually won't pick up the change to pod security policies. We go back and we can see that pod security policies will no longer be served from extensions v1 beta 1. It will now be served from policy v1 beta 1, which is interesting. So like, I mean, let's see if we can make it work, right? So pod security policy. Okay, so that got us configured. But one of the interesting points about this, and we're going to have to figure out how to fix this problem or how to address it, is that kubectl convert did not convert the pod security policy. So even though this tool is at our disposal, it doesn't quite work the way it could, and that's an interesting one. That's in my opinion, it's a bug. But I'll be filing a bug against a deprecated tool, so they'll probably tell me no. But that'll be interesting. So kubectl get pods -a final is up and running. And so that was just the networking component. We haven't actually even talked about like some of the applications or some of the other things that could be that could hit us here. But yeah, already I had to do more work to get Flannel deployed into a cluster that has those APIs turned off that I did to get it deployed that had those APIs turned on. Now, obviously, what I should do here and what I'm going to do is open a bug against the Flannel project and update that manifest so that it doesn't bite other people. But I thought it was interesting that, you know, like these are the things you're going to run into, not just with like things like, not just in places that you expect them, but also maybe in places that you don't, right? When I was discussing this with Joe Beta, I think it was a week ago or something like that, I was saying, we were talking about how like we might begin to create a spec for if we're going to develop an application that will be deployed inside of Kubernetes. And frequently, the example might be that you would just download an example spec that does kind of similar to what that you want to do, and then you would just modify it for your purpose, and then you'd continue on, right? Well, it's interesting that many of those examples make use of the extensions v1 beta 1 or beta 2 API group, and it's not necessarily true for the Kubernetes documentation team. I was actually just evaluating that, and a lot, if not all, of the examples there have already been updated, which is awesome. But there's, you know, like there's other stuff that is not updated, like this Flannel manifest, which is interesting. Let's take a look at some of the other things that may not be updated, and maybe like work through kind of a larger example or more kind of a better example of things that will not work. So to that end, you may not be aware of this, but there's like a project called SockShop. It's a microservices demo that Weaveworks actually puts out. And it shows off some really cool functionality of a project called WeaveScope. And I've seen people use it to demo Kubernetes and that sort of stuff. What if it's a matter of having multiple objects within one manifest? No, well, I mean, what do you mean by that? When you say, I wonder if it's a matter of having multiple objects within one manifest, what were you referring to? So the SockShop demo has a bunch of things that are still, you know, that will not deploy against this new version. And so what I want to do is I want to go ahead and grab that whole demo, download, and download it to my environment here. Git clone. So this is our old cluster. I'm just going to deploy to that cluster first and see kind of whether we can get the thing up and running, and then we'll put it on the new cluster and we'll kind of put out the fire and see if we can get that thing working there as well. So let's do kubectl apply -f microservices demo deploy Kubernetes. Okay, so it's just a race. Now all the things have been deployed, and if we do kubectl get pods -a, capital A, a new favorite command by the way, -A is the same as -- all namespaces. Pretty cool. We can see things coming up and being created. Again, kind of the user experience we're used to here. Is it smart enough to convert the API version for all outdated objects defined within manifest? Well, it did convert all of the deployments. I think that just convert doesn't understand how to convert pod security policies as an object. And so I suspect it's like a bug in convert, that it's not serializing all of the objects, it's just ignoring stuff it doesn't understand rather than erroring out about the fact that it's not known. That's where I try to use an imperative kubectl command, kubectl create, to start with for a new pattern versus pulling something from the web. Yeah, that makes sense. And then, yeah, so I think I've answered that question. I think what's happening there, my suspicion, is that convert just doesn't know how to solve that problem. So we've got things up and we've got things running. They're just kind of coming on slowly here as things start up, and that's okay. But as you can imagine, this is kind of a larger example. If I do kubectl get, so this is actually the thing I wanted to show before. If I do kubectl get, let's see, how would I go about this? Let's do kubectl get -a daemon set -n kube system -show labels. So let's do kubectl get daemon set kube flannel. And I am on AMD 64-OE YAML. So we can see that if I do a get, even on the old version, it still shows me the version that I persisted to when I created the object, right? So even though there's a new version of the group, because I created it using the old version of the group, it still stores the object as extension v1 beta 1, but it is compatible. So let me show you what I mean by that. So like if I do get daemon sets dot apps, and this is actually what they're referring to in the deprecated thing, right? So they're saying deprecated daemon set template generation. this API, this manifest, if I were to download that from the cluster, would be compatible with the forward version of Kubernetes. And so it does have a Kubernetes does have the capability of exposing a manifest that is forward compatible, but you have to kind of know how to get it. And as you can imagine, that's still a bit of work, right? So like even if I wanted to, this is actually one of the challenges I think around Convert, is that even if I wanted to go ahead and make that change or download the new version based on the changed version group, I'd still have to like understand what it was I deployed entirely and download all of those deployed things at the new version, and I have to explicitly say what that new version is, right? So if I do kubectl get pod security policy, I can see that there are two groups that pod security policies are defined in. One is the old extensions one, and one is the new policy one. And again, if I wanted to download the policy that was associated with Flannel, I can grab the one from kubesystem, and this gives me a compatible forward version of the policy. Right, because now it says policy v1 beta 1, but at the same time, like, I would have to know all of the things that I had deployed as part of that manifest and download them kind of individually. And so that's a little, I think that's certainly challenging. So I think the user experience is going to be a little tough for sure. I think it's going to be difficult for people to come around to that. So let's go ahead and kind of explore this other example a bit more. So I do kubectl get pods -n kubesystem. Sorry, cache-a. I can see that we're mostly up. We still have a couple things that are being silly, like shipping's not quite ready yet, and carts is not quite ready yet, probably waiting on dependencies or something. But we have been able to deploy it, and we're in a running state. Like pods are actually started. There are no restarts. So I'm going to call that success for the sock shop deployment in this cluster. And then I think it'd be valuable to go ahead and work through this on the other cluster and kind of see what we have to do to fix it up in the other cluster. So now we're back on our other cluster. I'm going to do top here and just kind of see, make sure I'm not beating it up too bad. Load average is kind of high. I'm going to go ahead and pull it from the other cluster so that we're not using all that compute. So I'm going to kubectl delete -f microservices demo deploy Kubernetes manifest. I'm not going to wait for the synchronous. So this is going to be fun. One thing I did want to, this is going to be fun. We're gonna have some fun here. So let's do this thing. So let's try first just to apply it and see what we get. So I'm going to do kubectl apply -f, or we could do create -f and just see what happens. Microservices demo, deploy, Kubernetes manifests. Oh boy, lots of things are not there anymore. Obviously, all of the deployments don't work the way we expect. And this output, right, so some services obviously were okay. But unable to recognize this, all of our unable to recognize this, right? So in this case, I have a bunch of deployments that are expecting extensions v1 beta 1. So would we be able to convert this set, since I don't see any errors about pod security policies? It's an interesting question. Let's try this out. So I do kubectl convert -f microservices demo. This is a GitHub repository, so even though I'm going to make this change, we'll still be able to use git diff to see what the new manifests look like. Okay. CD. So here's all of our manifests. I'm gonna get all sneaky and bash, folks. Bear with me. So we're in the no APIs directory. And the reason I want to be in here is because I want to make sure that the APIs that are registered with my kubectl client are there, so that I understand what APIs are available to me when I'm doing the convert. But that's an interesting thing. I am. I'm totally using DRM. Yes, I should have talked about that. Yeah, DRM is awesome. What I'm doing basically is when I move into one directory or another, I'm actually configuring my kubeconfig based on an environment variable that is loaded when I move into that directory, which is what Olav is pointing out. So when I move into the APIs directory, we can see DRM kind of talking about the fact that it's loading the envarc and it's changed our kubeconfig. And if I move back to the old directory, again, the change. And it's basically making sure that kubectl is configured appropriately for the cluster that I'm looking at. I'm also using a kind of Go status line thing that lets me know what cluster I'm looking at in my prompt, right? And that's where this like Kubernetes logo APIs, Kubernetes logo no APIs is coming from, which just makes my life a little easier to reason about when I'm moving back and forth between clusters. Thank you for calling that out. I should have talked about that as part of the setup. So let's see what we can do to get this to work. So what I want to do here, microservices demo, deploy, Kubernetes manifests. I got a bunch of manifests here. So what I'm going to do is for I in do kubectl convert -f $i greater than $i dash new probably not going to work though, is it? Because it just, yeah, so it's not going to take the path into account. So we have to do I need to keep that path. PTH, we'll call it, equals. For I in PTH star to kubectl convert -f PTH $i greater than PTH new. Done. What do you think, folks? Is it gonna work? Am I being too crazy? No, doesn't work. All right, cool. Microservices demo. Kubernetes, deploy, Kubernetes manifest. I move it here? Where to put it? Oh, that's not going to work, is it? Nope. $I. Complaining that, why is it getting the whole path though? Let's debug this. Echo $I. Oh, cool. It does include the path. TIL. All right. I don't need to include the path here. Boop, 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 boop. There's all of our news. Okay, so now I can do so let's go ahead and move this, just try and create the news, right? So I'm going to do make your deploy, move, let's see, microservices demo, deploy Kubernetes, manifest star.new to here, move star.new to deploy. So those are our new manifests. So now we can do for I in star to move $I to cool. So now we got our new manifest, we got our old manifest. And if I do a grep for API version, in here, I can see all of the versions line up with reality. So at this point, I should be able to deploy this whole set against our new cluster. All right. Yeah, I was surprised by that. Maybe that's a new bash thing. I remember like before it didn't, or maybe I'm tripping. Anyway, you know, things change. So let's do our kubectl. Yeah, I'm a little old school, you know, it happened. YOLO, I love it. Very fancy, yes, it's true. Yeah, so let's go ahead and do our apply on our new cluster. Got to do it twice because what's interesting is when you do apply into a directory, when you do apply against a directory, it takes it I think is it lexicographically? It's like ordered by the LS, right? So it's going to be ordered by the same way that we see it here. And you can see that the namespace is being created. It's like one of the last things that's being created. And so if I apply twice, then when the namespace gets created on the first round, all the things that are dependent on the fact that that namespace exists do get applied on the second round. And so that's actually that's the magic here. If I actually renamed Sock Shop NS to 00 Sock Shop NS, handy trick. Like if I do that, then what would happen there? I think only 4i in ls path. Oh, you're right. You're right, Bogdan. Because I was actually assuming Bash would iterate, would give me a list of all the files in it because I just did the path star. It was giving me the entire file path. But if I had said 4i in ls path, that's where I would have messed things up. Good catch. That's awesome. Anyway, so if I had actually moved the NS to 00 Sock Shop NS, then it would actually have applied first, and I wouldn't have had to do that twice. But it's one of those things, right? And really, like applying a set of manifests, like this complex a set of manifests a couple of times doesn't really hurt you anyway. And I think it's interesting. It's an interesting pattern for continuous deployment of manifests that you kind of have to work out like what the dependencies are because there are like obviously in this case a bunch of manifests that are dependent on the fact that a namespace exists. And so sometimes the ordering matters. And so sometimes you might see a deploy fail because you had not actually defined the deployment, the dependency before the actual thing that it was expecting it to exist. In this case, a namespace. There aren't too many examples of that inside of Kubernetes, I think, inside of the API, but there are some. Namespaces is one. Interesting stuff. So get-a and so that got us down the road. kubectl convert in this case really did help us out, right? So we were able to actually see the change. And so that got us to the point where these things are actually starting up on our new cluster without those APIs. But what we learned from our previous example was that kubectl convert's not going to catch everything. We may still see errors, and you may still have to do some hand tuning of manifests to get those things to create, depending on how much of those APIs you're actually making use of. So I thought that was a really interesting lesson learned, and I hope that you found that useful as well. I know that it's always kind of interesting to see what you're going to run into in these cases. The next thing I want to do is actually I want to just move into microservice demo, deploy Kubernetes manifests. And what I'm going to do now is I'm going to do git checkout -b fix remove APIs versions. That's our no API. Deploy star. So I can see, git diff. So there's all of our changes, right? And so we can see, oh, it's interesting. It has a bunch of information that it probably doesn't need to have, like revision history limit and progression deadline seconds. But it's updated it basically according to kind of the defined spec. So we'll leave them in there. That's what kubectl convert's adding. So it's adding like the creation timestamp field. Even though if it's not there, it'll still get picked up, and that's fine. It's adding the image pull policy always. Wow, that's fascinating. I mean, it's good, but it's like funny that it's doing that. It's setting the termination policy or message path to dev termination log and setting it to file. This is actually really handy because it basically means that you could do kubectl logs on a terminated pod and see what happened, and so that's kind of handy. It's changing the structure. Okay, that's still here. Still medium time memory. It just changed. It just added some other fields. That's out of order there a little bit. No big deal. No changes to the service definition. Went ahead and added the creation timestamp. Added protocol TCP. Actually, added session affinity none because it wasn't defined. Instead it was cluster AP. Went ahead and added the empty status piece of this. These are what we're looking at here is what kubectl did to modify these objects when I did the kubectl convert, right? And so we're just adding, we're seeing those things that kubectl convert added to the objects. What is the difference here? So this is, oh, it added a dash for the env because it's a new object, maybe. Interesting. So it's changing the order. Oh, it's because it. Yeah, this is interesting. So it's because it's in a different order. Like it started the list with env now instead of name, and so it's just an ordering thing. It doesn't actually change any of the values. Leaving image pull policy if not present. Oh, it's just changing the order again. No big deal. Yeah. And so these are, and so this was now successfully deployed. It'd be interesting to go ahead and evaluate, like as a consumer, whether this was actually enough to fix the problem for this particular application as it relates to version 1.16. So remember, this is a great experience to this is a great way to actually validate these things and then to go ahead and push your changes before 1.16 comes. And so in my example here, what I've done is I've created a branch. And I can see that my changes actually modified all of these objects that are in my output. Here's like a bucket of YAML that this particular application is deployed with. And because I've modified all of those things, I want to go ahead and apply that change to the manifests as they're stored in GitHub so that the next time somebody deploys this application, they're not caught out by the expired APIs. And so I am probably going to make a pull request for this, but I figure the reason I'm not going to do it right now is because there's all these other manifests that probably should also be changed, and so I'm gonna do that like all at once rather than kind of like doing all these parts a part of it. Now in this directory, there's one more thing I want to touch on, which I think is also interesting, and that is Helm charts. And the Helm charts are really a trip. What are we looking at here? So I'm checking out the chat again. I think kubectl convert does kind of like a dry run. It kind of does. It'll take the entire content and convert it and just provide you the converted files. As far as I know, kubectl convert doesn't do in place. So it'll do recursive. Yeah, there's no, it'll output into a list of converted manifests rather than output into a file. Like the only output options you have are like whether it's JSON or YAML or that sort of stuff. It doesn't really change. It can't do it in place. And so there's that. All right. Helm. Helm is really interesting. Let's go look at Helm real quick. So here's a Helm chart that deploys all the same stuff that I was actually just deploying. So here's all of our manifests. And again, if we look at them, or if I do grep API version inside of these manifests, we can see that all of the things that were out of date are not are still out of date in these manifests. And if I do kubectl convert -f cart, and this is going to be a thing I think people are going to run into, dep YAML cart db dep YAML dot new diff -u cart dep YAML and cart dep YAML dot new. So it definitely picked up the change to the API group, which is good. It added the stuff that the manifest usually adds. Oh, okay. Well, in this case, it actually did the right thing. So converting these would actually have done the job. But what I was looking for is mustache templates. So let's see if we can find one that actually has that. Let's see, Helm. Let's go ahead and move back a few directories here. Helm, fetch, Nginx, stable, stable Nginx. Okay, fine. Oh wait, I can just do a Helm search. Helm search Nginx. I think this one has mustache templates a little further in. Let's take a look and see what we see. So so our daemon set is expired. So this is a stable Helm chart that probably quite a few people use to deploy the Nginx ingress controller. And it is not updated. And I imagine that you're going to find any number of public Helm charts that you might depend on are in the same state. So I want to call that out. Like, I think it's important that we understand that case and that we fix it up, right? So both the daemon set manifest and the deployment manifest are both like outside of their configuration at the moment. And the pod security policy also not going to apply, right? Like those changes that we had to make to the other manifest, we would have to make to this. Let's take a look at whether we can use kubectl convert to fix this problem. But to understand that, I need to look and see if we're using kind of like the mustache capability of this stuff. And so let's do cat controller deployment. There we go. So then we have a whole bunch of stuff that's all up in the manifest here in this YAML that is taking it from the configuration that is making use of the templating capability of Helm. And I suspect that if I tried to convert this file, it would complain loudly at me. But let's take a look and see what we see here. So I do kubectl convert -f controller deployment. It says error parsing, and then we can see it pointing at the mustache template. So because we're actually using the templating capability of Kubernetes, and convert does not understand how to parse the file because there's all this extra stuff in there that Helm understands, but kubectl does not. We can't fix that problem as it sits. But here's something that we could do, and this is not going to work for all Helm charts, but it may be a way forward for some Helm charts. This one in specific will actually it'll help with. If I do Helm template, so I'm just going to take the default configuration. So in Helm template is a way of basically using, actually, I'm going to let them describe it. So So what Helm template does is it renders chart templates locally and it displays the output, right? So in my example, what I'm trying to do is make sure that I can um, render the template so that I can see what the resulting manifests would look like. And then I can take those resulting manifests and convert them so that they are deployable. So in this example, what I'm trying to show is I've got a Helm chart that is using all of the templating capabilities of Helm, and I want to go ahead and uh, fire up the templating part of this locally, and then I will take the resulting manifest from that Helm template output, modify it to make it compatible with my new version of the cluster, and then validate that I can deploy that new version. I know that's a lot of words. I'm going to try and take another shot at explaining it real quick. So Helm has this templating capability. What I'm using here is Helm template, the Helm template subcommand, which allows me to make use of the templating capability based on a values file, and it will produce the actual manifests that I would use to deploy this application based on that templating capability. Now, once I have those manifests, then I have something that kubectl convert can actually modify, and so that I can actually leverage kubectl convert directly to modify those things before I deploy them. And that's what I wanted to point out. I hope that made sense, but that's what I'm going for here. So if I do Helm template, and then I do less, then we can see what the resulting manifest looks like. And so we can see a source line, we can see the versions of things, and so here's like a service account, a cluster role, all the stuff that goes into defining those things around RBAC for the Nginx ingress controller. Here's the role for it. And then down below we get the role binding. We've got our service defined, another service defined, and there's our deployment. And so here's the thing that we need to change. Can we convert this thing on the fly and get it to deploy in our new cluster if all we have to, if we have this resulting manifest? I think that'll be interesting. So let's give that a try, shall we? So let's do Helm template dot. Actually, let's do this. Let's do make dir Nginx manifest. We'll do Helm template dot. So now you have our manifest, and if I were trying to apply this against our existing cluster, right? If I do kubectl apply, Nginx manifest, then I get told nope for all kinds of interesting things. Oh, apparently the name's too long also. I'm probably going to have to fix the name. Doesn't like release name. It created the cluster role, it created the role, and then it complained about the config map because the name, oh, it needs to be lowercase. Okay, so we'll do kubectl delete -f. So what that's telling us is that I have to like provide a little bit more value than just like trying to template it with against the defaults. I need to actually set release name to something that is not totally jacked. So let's go back into the template and we'll just template that again to fix that problem. So Helm template help. -n Nginx test. Convert. We'll call it convert. And Nginx manifests. No APIs. Try and apply that again. Let's just do dry run, that way we don't have to delete it later. Looks like it actually almost worked, right? Like I was able to apply most of the things, but the only thing holding us back right now is that deployment object. So let's try to convert it. kubectl convert -f nginx manifests kubectl apply -f. And then we're good. So what that just showed me was that I could use convert to change this, and that would at least allow me to modify the resultant manifest, but it would not, of course, change the fact that my Helm chart has a bug. And to do that, I would have to actually go back and change those fields in the manifests, probably by hand, for all of those things that it could apply. And so this is what I'm trying to say. This is gonna bite a lot of people. There's gonna be a lot of people out there doing Helm install and doing doing things that people do to basically try to make things work, and it's gonna bite them. And so that's where we are, and that's some of the things that you can do, and some of the things that you're going to experience and see in the field when people are actually trying to deploy manifests that work just fine in 1.15 and are not going to work in 1.16. So I say again from the beginning, please, 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 tell all your friends. It's important. Can I do? Yeah, that's a good question. So let's try that real quick. I guess technically that's what I did here. Oh, I see. I don't think it's going to work. I don't think that kubectl apply -f. Let's try that though. So I'm going to go into the APIs group again. And what I'm going to do is I'm going to do kubectl apply -f nginx manifests. That's the old version. Dry run -o YAML. Good API version. Let's no. What if I do this though? What if I did? No, that won't work. Yeah, because the problem is that I need to be able to specify the version that I want exported. Can I do that though? That's a great question. I'm actually kind of curious. pretty sure the answer is no. And here, the reason for the answer being no is that I have to deploy the thing, and then when I try and get the manifest that has been converted in place through storage, I have to know what target version I want to download. So if I've applied it as extensions v1 beta 1 and I do a get, just a straight get, then I'll still see extensions v1 beta 1. But if I do get apps v1 for that same manifest, then it will allow me to download that, but I have to be that level of explicit. Yeah, it's a good question though. That was an interesting one. I think did I get your thought correctly, Bogdan? Did I answer the question that you were looking at? I hope so. All right. Well, I mean, that's what I wanted to share with you, and I think it's super important that we catch it. Um, Thank you all again for spending your afternoon with me. We've been at this for about an hour and a half, and I think that covers the problem pretty well, and some of the things that you can do and what you can expect. Obviously, there are myriad ways to fix this problem. Like if you are actually if you have manifests that you need to fix, I was showing you what I suspect is what it's going to be most people, which is that like we're going to have to like go through and modify all of our manifests to support this new version. Like all of the code that you have in a code repository anywhere that you've used to store those deployments that you've been using over the last bunch of versions of Kubernetes, you'd need to go through and evaluate whether they're still viable to deploy in 1.16 before you deploy 1.16. And you can do that manually. You can go through and just like change the API objects. You can codify that. There's tons of ways to do it. Some of the interesting ones that we talked about are conf test, which is a good way of actually evaluating manifests and things in place. Rego is actually a really powerful thing to allow you to kind of do that testing, because it's not, unlike kubectl invert, it's not specific to the way that Kubernetes itself works. It's actually just trying to look at it as like a generic policy language problem. Yeah, there's lots of ways to fix this problem, but I'm confident that we're going to find even more ways than I can think of right now to fix this problem, because I know that we're going to run into it. Thank you so much for your time. Any other questions that I can help with before I go? Or are we in good shape? That blog post, once again, get it out there. Go talk about it. Yeah. Don't let it catch you by surprise. Thank you all. And I hope you have a kicking weekend. I know I'm looking forward to my weekend. I still have slides to beat up on for my presentation at Black Hat that I'm co-presenting with Ian on. So thank you.